Let's see this question. Construct a minimal finite automata for all strings over the sigma a comma b, where each string starts with a and the length of the string is 0 mod 3. It means it is divisible by 3. Each string is of the form ax, where x can be anything from the alphabet a comma b, and the length of each string is divisible by 3. So it is congruent to 0 mod 3. Right? We have seen this question. We have seen how to construct a DFA for strings starting with a, and we have also seen how to construct a DFA for strings having length divisible by 3. Right? Let's quickly draw these DFAs for each of these languages. Now we have two finite automatas, F1 and F2, corresponding to F1 corresponding to, let's say this is language 1 and this is language 2, right? F1 corresponds to L1 and F2 corresponds to L2. So we need to connect F1 and F2 so that we'll get a language where each string starts with A and each string is of length divisible by 3, right? So let's look at what all the strings we have in this language. This is combined language. L will have strings from L1 and L2. This is not a concatenation, but think of it this way. There is a function which connects both L1 and L2, which gives our language L. So the language L will have strings like epsilon won't be there in this language because of this constraint, right? So every string should start with A. So epsilon will not be in our language. And what are all the strings, what are all the lengths each string can be? It can be 3 or 6 or 12 or 9 or 12 or 15 and so on. All these are multiples of 3. Each one leaves a remainder 0 when divided by 3, right? So each string should be of length 3 or 6 or 9, any of these, right? So, and also each string should start with A. So the strings are A, AA, A, BA, AB, B, AAB. These are all the strings we have of length 3. And similarly, we can have strings of length 6 also. And so on. These are all the strings of length 6 and so on, right? These are all the strings which we have in our language. You can clearly see that each string starts with A. So while constructing the finite automata F having F1, some function which connects F1 and F2, this will be our final finite automata while after connecting F1 and F2, right? So here S is our initial state, start state, and F is our final state, and D is dead state in F1. Q0 is our initial state and also final state, and Q1 and Q2 are two other states in F2. You can refer the previous videos for construction of these two finite automata, right? So we somehow need to connect F1 and F2 to get a resultant finite automata which accepts the given language, right? If we see the initial state of F1, which is S, on seeing A from S, we are going to a final state here, right? But we cannot have this final state anymore in the resultant DFA because we should not end the string, we should not accept the string on seeing just an A. We should be waiting for any of these two symbols to occur after seeing an A, right? So we cannot have this this state in our resultant finite automata anymore. So now the question is, on seeing A from S, where should I go? Right? You should go to that state from where you can see two more symbols and accept the string, right? If you consider this set, on seeing A, I have two more symbols. Either it can be A or B. I'll have to wait for two more symbols to occur, and then I may go to final state if the string is ending there, right? Because all these strings are divisible by, the length of all these strings are divisible by 3. In the same way, the lengths of all these strings are divisible by 3, right? So ideally, I should be going to Q1 on seeing NA from S. From Q1 on seeing either A or B, I will go to Q2, and from Q2 on seeing A or B, I will go to Q0. If the string ends here, I will accept it, or I will just continue to Q1, and from there look whether the length of the string is divisible by 3 or not, right? So the final DFA for accepting this language is, let me draw it quickly. So this is our finite automata after construction from F1 and F2. This is just some function. We don't know what it is, but it connects F1 and F2 so that we get a resultant finite automata. In this finite automata, we have a dead state, we have one final state, and this every string starts with A, and each string has length 3. This essentially counts the length of the string. This loop essentially counts the length of the string, and this one is there to see if the string is starting with A or not. If it is not starting with A, it will go to dead state.